Hi there, this is GCSE Physics. This is particle model, and this is lesson 7. And this is the specific heat capacity and latent heat level 9 exam style question. And the objective is to attempt the mad hard extension question. And this is it. If you want to have a go at it, this is a level 9 question. So if you want to pause, have a go, and I'll take you through the answer. An ice cube is a temperature of minus 10 degrees Celsius. The total thermal energy needed to raise the temperature of this ice cube to 0 degrees Celsius and completely melt the ice cube is 48,500 joules. We've got the specific heat capacity of ice at 2,100 joules per kilogram per degree. We've got the specific latent heat of fusion of ice at 334,000 joules per kilogram. Calculate the mass of the ice cube. So in terms of energy, it's pretty straightforward. So we've got a total energy. So I'll just write T for total. Must do two things. So that 48,500 joules of energy has got to do two things. First of all, it's got to change the temperature of the 10 degree ice. So we've got a temperature increase. So I'll just write temperature has got to go up. Plus, we've got to melt the ice. And that's it. So then we just need to write the equations. So the total energy is 48,500 joules. And that is equal to, now the equation for describing the temperature increase is the specific heat capacity. So that would be mass times the specific heat capacity, C, which would be 2,100, times the change in temperature of minus 10 to 10 is plus 10. So, but I'll just put MC theta, plus the energy required to melt the ice, which is going to be E equals ML from the previous lessons. So plus ML. So now we've got the total energy, 48,500, is equal to the energy required to change the temperature plus ml, the energy required to actually melt the ice. Then we just need to put some numbers in. So 48,500 equals, what we should do first of all is factorize this. So pull the m out of both of these, MC theta and ml. So let's take the mass out and then brackets. So specific heat capacity times change in temperature plus the latent heat of fusion L. Close brackets. So let's put some numbers in. So 48,500 equals the mass, which we'll get in a moment. Bracket, we've got C, specific heat capacity of ice, which is 2,100, multiplied by 10, because that's the change in temperature. It's gone from minus 10 to 10, so it's positive, plus the latent heat of fusion, which is 334,000. So we can figure out what that is. So we've got 48,500 equals the mass times the bracket. If you put that in your calculator, it's 355,000. So 355, 3 zeros. Then it's pretty straightforward. We just need to make M the subject. So we just need to get rid of the times 355,000. So we're going to divide. So the mass is equal to 48,500 divided by 355,000, and that gives us a mass that's equal to 0.14 kilograms. If you got that right, then you're basically a genius, and you'll probably get a grade 9 overall. Just make sure you learn your definitions. If you didn't quite get it right but got halfway there, you've still done really well. And even if you didn't know where to start, now you've seen a question like that, you could go back, try the question again, obviously without your notes, and see if you can figure it out this time. So I hope you enjoyed that. Thanks for watching, and I'll speak to you soon.